All right, moving on to U substitution. So honestly, I didn't really like any of the questions that were on the practice exam. And I really, really, really like this one. Okay? So, if you know what I'm saying. All right. So, on the test, it'll tell you to use U substitution and it'll tell you to state U and DU. Okay? So, what we're going to do here is we're going to think about what we're looking at. I know this was a integral that we did already in class, but as a little refresher. So I have cosine of a function, okay? Cosine of pi t over 2, right? If this was just cosine, well, I know its antiderivative is going to be sine, right? I know this. But I have to take care of this, and that's why we need U substitution, okay? So, because cosine isn't the problem, that means we're probably not going to need to take cosine as the U, right? You want to take care of the problem, all right? So let's do U as pi over 2 times t. Now again, it's going to say state U and du. Really, you need to state your U and then calculate your du. Okay, it's a little bit misleading in my opinion. All right, derivative of a number times t is just the number. Remember, pi over 2, just a number, okay? Don't freak out on me. Okay, so this whole thing becomes U because that's what we said it was equal to. So we get integral 0 to 1 cosine U. Now, what's going on with this dt here? Well, let's solve for dt here. dt is going to be 2 over pi du. So we replace dt with 2 pi du. Anytime you have a constant, for the love of God, just put it in the front and we'll deal with it later. Okay? Because we can. So we're going to. Alright, like I said, we know the antiderivative of cosine. So we're good because the problem was taken care of with the U substitution. So this becomes 2 over pi times sine of U. But our initial integral was in terms of t, so we need to make sure our answer is also in terms of t. Remember, this is what U is equal to. So we get 2 over pi times sine of pi over 2 times t. And we want to evaluate this from 0 to 1. On the test, it will be a definite integral, but we are giving you the unit circle, so use your unit circle. So from here, we'll get 2 over pi times the sine of pi over 2 times 1 minus pi over 2 times the sine of pi over 2 times 0, which is pi over 2 sine of pi over 2 minus 2 over pi times the sine of 0. So that means we need the sine of pi over 2 and the sine of 0. So we go to our unit circle. Here's pi over 2. Here's 0. Remember, these things on the unit circle is cosine, comma sine. Okay, so the sine of 0 is right here. And the sine of pi over 2 is right here. Okay, so we get 2 over pi times 1 minus 2 over pi times 0, which is 2 over pi. Because we're giving you the unit circle, please don't leave it like this. Leave it like this, because you can do it. All right. Just as, not a word of caution, but maybe something to just remember about your table of indefinite integrals is I have secant squared here. Secant squared gives me tangent. Secant tangent gives me secant. Cosine cotangent gives me negative cosecant. And cosecant squared gives me negative cotangent. Okay, so if you see something similar where you're like, I know it's antiderivative, but there's something in between here that I don't know how to do, take that as your u. The input of your trig term is going to be your u, because you can take this antiderivative once you get rid of the u. So you could see something with any of these. So just keep that in mind.